All right, so when we began this whole process back in the beginning of the 9 weeks, we watched a video. That video was, of course, about Deo's former hometown, Flint, Michigan, and how everything was okay. It was an old town, there was lead in the pipes, everything was okay until they changed the water. When they changed the water, it changed the acidity of the water, and the acidity caused the lead to come out of the pipes and into their drinking supply. So, this is one of the last things we're going to talk about before we're finished with this unit, and that is what are acids? For that matter, what are bases? So, here we go. If given a formula, I can distinguish between acids and bases. Given a pH, I can determine whether a solution is acidic, basic, or neutral. What pair of substances play a major role in water quality? Acids and bases. Acids and bases. Acids and bases. Yes, please start on the side of the worksheet that has the number 1 on. What are acids? Basically, if it begins with an H, it's an acid. What about water, Mr. Marino? Okay, water can be thought of as an acid. How about that? If it begins with an H, it's an acid. That's not always the case, but in this class, it will be. An acid is something that can detach off a hydrogen ion. So in order for it to detach off a hydrogen ion, it has to have a hydrogen ion. Some examples. Carbonic acid is in your soft drinks. It's H2CO3. Soda fizz is what carbonic acid gives us. If your toilet or your tub is so dirty that detergent can't get rid of it, your parents may have to use muriatic acid. Anybody here have a boat at home? Your parents have a boat? When you start seeing green stuff on the boat, he uses probably this chemical called muriatic acid, and it takes it right off. So that's hydrochloric acid, begins with an H. Ascorbic acid, it's an H plus a bunch of carbons and hydrogens and oxygens. It's pretty complex. Ascorbic acid is what we call vitamin C. Acetylsalicylic acid is aspirin, and it begins with an H. So if it begins with an H, acid. What are bases? Substances that contain hydroxides, OHs, at the end. Sometimes it can even make hydroxide by tearing it off of water. So either if it has hydroxide or it can make it in water, it is a base. Calcium hydroxide can be found in plaster. If you ever made a paper mache anything, you use calcium hydroxide. Sodium hydroxide is oven cleaner or toilet cleaner, drain cleaner. Magnesium hydroxide is antacid. It's what's in Tums or milk of magnesia. And sodium bicarbonate is what we call baking soda. It does not have a hydroxide, but it creates a hydroxide. See, I am on antacid medication. My stomach produces a lot of acid, and it irritates it's called a sphincter, but it's a little trap door that opens as soon as food goes down your food pipe. It opens up and allows food to go into your stomach. So it is at the tail end of your food pipe, your esophagus, and it opens and closes real quick. If it gets stuck open, which is what happens with me, the acid that is naturally in your stomach will squirt up into your esophagus, and it'll start burning your esophagus. Okay? And it feels like you're having a heart attack. I've never had a heart attack, but when my heart hurts, I know that I've got really bad heartburn. Now, why doesn't that happen to your stomach? Because your stomach creates this layer of slime on the inside that protects it. If ever you get under a lot of stress and emotional and all this stuff, sometimes that layer gets worn down. And if that layer gets worn down, then the same thing that happens to your food pipe will happen to your stomach. And then you get holes in your stomach called, anybody know? Ulcers. When you get an ulcer in your stomach, then your stomach starts leaking hydrochloric acid into your mesentery, into your gut, and that starts dissolving away your intestines and it's very, very painful. No, that's just like I mean, if we were to eat something that was like really bad for us and our stomach would regurgitate it, then that would be like chocolate. Except the chocolate gives them is like a high, it gives them and then eventually it when they crash, sometimes their heart will actually stop. So yeah, my when I was a kid, when I was younger, um, we were nearly married. We had a dog that got into a box of chocolates. $300 later, after going to the emergency room, we brought her back because she was just in bad. She would have died if because they have to actually give her kind of like a stimulant to keep her heart going so that her heart doesn't stop. So do not give dogs chocolates. So yeah, there's a really nasty acid. You have tasted the acid ever um, thrown up and gotten this burning sensation in your mouth and in your nose? That's from the acid in your stomach. Think about it. The acid in your stomach's job is to break down, to decompose, to dissolve away the food that you're eating. So it's got to be tough. It's got to be tough. If you ever vomit so much that what you are vomiting into the toilet is a bluish green liquid, then you have nothing in your stomach except for acid. Except for acid, yeah. What are neutral substances? They are neither acidic nor basic. They are neither acidic nor basic. Examples. Table salt is neither begins with a hydrogen or ends with hydroxide. So it is neither acidic or basic. Sugar is neither acidic or basic. What is a neutralization reaction? When an acid meets a base, they dissolve each other. They counteract each other. I never finished my story. Back when I was a kid, I used to have a lot of heartburn. I'm on medication now. So it got to be really bad before I would go and complain to my grandmother who raised me. And because I know what would happen, my grandmother would turn around and get this bottle off the shelf of this white powder, get this big old spoon, spoon it in, and she would say, "Open your mouth." I would go, "No." And she would get that sucker in my mouth. Oh, I can still taste it to this day. Baking soda. She gave me a spoonful of baking soda. Who's ever had baking soda? Grandma, you know what I'm talking about. It is vile. It is very, very bitter. But in her defense, within minutes, right, Wes? First of all, within minutes, this is what starts happening. You start burping up a burp storm. It's like, and then your stomach calms down. It really does. Now, what works a little more gentler, but not as ferocious, and it tastes better are Rolates. Okay, so Rolates are going to be magnesium hydroxide, so it's still going to work to neutralize the acid, but it works a little slower. But it is a whole lot tastier, though. So yes, okay. Either you upset your stomach and it overproduces acid, or you get that little trap door stuck open, and as your stomach is doing normal things, it squirts the acid up your food pipe. So either way, you get heartburn when you get acid in your food pipe because your stomach has that slime layer, but your food pipe does not. Your esophagus does not. And neither does your nose or mouth. That's why it burns so bad when you vomit. So, in review, acetic acid, vinegar, anything that tastes sour to you, your sour bones, no, what are they called? Hammerheads? Warheads. Warheads have citric acid on it. Anything that tastes sour is going to be acidic. Anything that tastes bitter is going to be basic. Ever gotten some soap in your mouth? That's a base. That's a base. So carbonic acid is in your drinks. Hydrochloric acid is used for cleaning. Nitric acid is used for fertilizers, dyes, explosives. Phosphoric is if you want your drink to be a little tart, you add phosphoric. Sulfuric of all of these is the most useful. It's used in huge amounts. Paper companies. Ever gone by a paper mill and you go, oh man, who did that? That's because of sulfuric acid. Okay, paper companies use a lot of sulfuric acid. For in my family, it was Sandra. It didn't matter who did it. Sometimes it was me who would pass gas. We would always blame it on Sandra. Is that the same thing for y'all's family? There's always one scapegoat. Casey, that's you, isn't it? No, you're always to be blamed. And it was probably for that one time that you felt really bad and you did that. And then all the others have not been your fault, have they? So yeah, we used to blame Sandra for everything. Calcium hydroxide is in mortar and plaster and cement. Magnesium hydroxide is milk of magnesia. Ever have milk of magnesia? Potassium hydroxide is in liquid soap, and sodium hydroxide used to be used in soap. If you go to Dollywood, it's sodium hydroxide. They make it out of sodium hydroxide. It's still a major industry product. How do we measure how acidic or basic something is? It's not the scale, it is the pH scale, where I like to think of it that the pH stands for the power of hydrogen. Hydrogen, hydrogen. The power of hydrogen. Anyone remember from middle school, if you are an acid on the pH scale, what numerical values will you have? What range? No one remembers. 0 to 6.9. The pH scales goes from 0 to 14. And from 0 to 6.9 is an acid. An acid. What if you're neutral? What is going to be your numerical value? 7. I'm a perfect 7. I'm a 7. 7, 7, 7. 7, you are neither acidic or basic. Why are you giving me that look, Casey? You have a heart. I have heartburn. Look, do you have heartburn? Does this class give you heartburn? What is the base on a pH scale? 7.1, 2, all the way to 14. Now, rainwater is naturally acidic, and it's very important that it is. It is naturally acidic because of a gas that we have now outlawed, Carbon dioxide, bad, bad, global warming. Well, no, it's not. Maybe too much carbon dioxide is bad, but the fact is, carbon dioxide is naturally in the air. It gets mixed up with the rain and it comes down. So, rainwater is naturally acidic. Why is it important? Because where do trees and plants get their nutrients from? The soil. How does the soil get nutrients? From rocks. How does the rocks get in the soil? Rainwater, because it's acidic, is going to dissolve rocks. If rainwater was not acidic, it would not dissolve rocks. There would not be any nutrient in the soil. Therefore, plants would not live. So we're very happy to see for CO2. Fish are the same way. They can only tolerate a narrow range from 5 to 9. Back when I was in my early 20s, I worked in a lab at a university. I don't know what kind of mind thinks of doing this, but they did it. We had one of the things I used to take care of was this aquarium that had freshwater fish and crayfish, crawdads in it. I love the crawdads. They were so interesting. Okay. They were always chasing after the fish, trying to get the fish. Um, then the ecology class did a survey of the water survey of water that was near a dam that had been polluted. And they found some crayfish in the water and they brought them back and they put them into my aquarium. So now I had store-bought crayfish. Actually, it's not store-bought. We got it from a company. Uh, Store-bought crayfish, store-bought fish, and then crayfish that lived in a polluted pond. And then somebody came in, found a jar of hydrochloric acid, and poured the hydrochloric acid in my aquarium. So on Monday, when I came in to feed all the fishies were swimming like this with their tummies up into near the surface. They were all dead. All my crayfish were dead except for the polluted crayfish. By pouring the acid into my water, it damaged the water so much that the normal crayfish and the normal fish could not survive. They all died. The crayfish that were used to living in very acidic water survived. So, here we go. Stomach acid, very acidic. Lemons, vinegars, soft drinks near pH 2 to 3. Oranges, a little bit past 3. Tomatoes, bananas, all acidic. Black coffee, rainwater, milk, all of it acidic. Okay? By the way, why is milk acidic? What acid does it have that some of you are allergic to? Lactic acid. If you're lactose intolerant, you cannot digest lactic acid. All right, pure water, right at 7. Blood is a little bit basic. Eggs, soap, seawater, milk of magnesia, household ammonia, and drain clean. Can you go beyond 14? Yes, but not naturally. Can you go below 0? Yes, but not naturally. The whole purpose of the pH scale is to tell us what naturally occurring chemicals fall into, how acidic or basic they are. We can make acids stronger than nature does, and we can make bases stronger than nature does. So, football players, your physical trainer is always on you to do what? Eat better and drink plenty of water, right? Because you have a bunch of dissolved ions in your blood. They're called electrolytes. 2 of the dissolved ions that are going to be in your blood are going to be things like hydrogen ions and hydroxide ions. So they are also electrolytes. What happens is this: you exercise, you naturally produce acids when you exercise, Jacob. So you're really working those quadriceps right here, down here. You're working them, you're running a lot, and you're not drinking. So you have this enormous amount of acid going on in your quadriceps to the point that the muscle tissue just simply cannot survive there anymore. So it'll just freeze up on you. What do we call that, Jacob? A cramp. Okay. And the only way, I mean, for football players in the NFL, they're always drinking. You rarely ever see them, but they actually, if it gets so bad, if it gets so hot, you'll see actually football players in the NFL in on the sidelines with IV bags. Yeah, trying to get water back into their system as quickly as possible.
Electrolytes are charged substances that make a substance electrically conductive. They result from a process known as dissociation, which occurs when a polar compound separates into its component ions. Electrolytes are important components of body chemistry that promote proper cellular function, regulate water levels, and play vital roles for muscle, nerve, and brain function. Like potassium, calcium, magnesium, and salts, acids and bases are also electrolytes. An acid is a substance which functions as a source of hydrogen ions in aqueous solution, while a base is a substance which functions as a source of hydroxide ions in aqueous solution. Acids and bases can be found virtually everywhere. Examples of acids include lemon juice and household vinegar, while baking soda, ammonia, and bleach are bases. In fact, with the exception of water, almost every liquid that we encounter in our daily lives consists of acidic or basic properties. The human body secretes and produces several different types of acids. For example, parietal cells in the lining of the stomach produce and secrete hydrochloric acid, which works to digest food. Another important acid in the body is carbonic acid, which comes primarily from carbon dioxide combining with water in the bloodstream. A special quality of acids and bases is their ability to neutralize each other's properties. In an acid-base or neutralization reaction, the hydrogen ions from the acid and the hydroxide ions from the base combine to create water. Salts are also products of neutralization reactions. The measurement of a hydrogen ion concentration in a liquid determines its pH value. pH is an acronym for potential hydrogen. It is essentially a rating system that indicates a liquid's relative acidity or alkalinity, a term commonly used to describe base properties. Every liquid has a pH value, which falls on a scale between 0 and 14, with 7, the pH of pure water, being neutral. A pH value less than 7 is acidic. Values greater than 7 indicate alkalinity. Battery acid and vinegar, two very acidic liquids, have pH values on the lower end of the scale, while baking soda and ammonia, both of which are very alkaline, are on the higher end of the pH scale.
All right. Any questions on acids, bases, and pH? Let's talk about polar versus nonpolar. Watch the greatest science video of all time and explain why like dissolves like. What are most substances found in rivers composed of? Molecules. Non-metals form molecules instead of ionic compounds. What is the difference between them? Molecules share electrons. Ionics give or take electrons. Moleculars share electrons, whether evenly or unevenly. Ionics are going to give or take electrons. What is the difference between the two types of moleculars, polar and nonpolar? Some share electrons equally, while others share them unequally. All right, let's use Oscar. Do you have a girlfriend? Matthew, anything? I need a Jacob. You got a girlfriend. Okay, so Jacob and his girlfriend are hilarious. Okay, you see them at Dairy Queen. He buys her a burger. He buys himself a burger, and because he's not wealthy, he buys a large bag of French fries that he intends for them to share. And she takes the French fries and she takes out one French fry. She goes, "This is for you, and one for me, and one for you, and one for me, and one for you, and one for me." Okay, until she gets to the last one. And if it's not even, then she goes, "Jacob, I've done all the work here, so I'm eating this one." All right, even Stevens, every French fry is evenly distributed. That is a beautiful sharing relationship. You should all aspire to be in a relationship like Jacob and his girlfriend. Okay, what about you, Austin? Girlfriend? Deo, girlfriend? We're going to make believe you do. Okay, you and Ariel, back when you were not dating. All right, so I noticed them. I at Wendy's one time. Okay, I was just sitting there watching the whole thing. It was one of the saddest things I've ever seen in my life. Okay, so this is one of the saddest things. So I saw Deo coming with a tray. He had a large bag of French fries and two burgers. He gave a burger to Ariel and he took a burger for himself. And then I saw Ariel reach over, grab the entire bag of French fries, and put it on her tray. The look on Deo's face was like, I mean, his lower lip started quivering. And he goes, can I have some French fries too? And then she did this with her face, rolled her eyes, grabbed three French fries, put them on his tray, and that was it. She ate the entire. Did they technically share the French fries? Yes. But was it like Jacob and his girlfriend? No. It wasn't equal sharing, it was unequal sharing. Okay. And what resulted was positive and negative side. She was negative for doing that, wasn't she? Very negative. Okay. And poor Dale with his lower lip quivering, he was the positive side. So if you do not share your electrons equally, you create positive and negative sides. If you share them equally, you have no sides. No sides. Let me show you the greatest video of all time. Here's Deo and here's Ariel just taking all the French fries, all of them. No sharing. Take all the French fries. That is ionic. Notice that poor Ariel now, or poor Deo now has no electrons. So he is positive. And this is Ariel. She's negative. That's ionic. That's not what we're talking about. But for some strange reason, Deo, now that Ariel's taken all the French fries, Deo thinks that Ariel's even better looking and he wants to stay with her. That's an ionic compound. Now let's look at Jacob and his girlfriend. Oh, look at that. Sharing, share and share alike. Their kindergarten teacher would say, "Good boy, good girl." Sharing. Notice that they have equal grasp of that chew toy. So There is no positive side, there is no negative side. Okay, so that is Ariel, and that is poor. Look at poor. No, no, this. I want this. I want to play with this true toy too. Watch what Ariel does. You telling her all this? Good. Ah, look what Ariel's doing. Poor Deo. Poor Deo. Look, oh man. So are they technically sharing? Look at Dale's face. He even looks like it. Oh man. Is it equal sharing? So we say that Ariel is more negative than Deo, so she's the negative side. There's Ariel and Deo. Was that not the greatest science video of all time? Really? You have no heart. You must be a cat person. I knew there was something wrong with you. How does this affect substances' ability to dissolve another substance? It's called like dissolves like. Polar can only dissolve polar. Nonpolar can only dissolve nonpolar. Ladies and Byron, your nails are polished. Well, this is something most of us don't ever think about. Most of us guys don't ever think about this, but Byron's going to have to think about this. Okay? Why? Nail polish. Is it non-polar or polar? Let's think about it. Like dissolves like tells us that if it is polar, water is polar. Water is very polar. So if it is polar, then the next time he goes to wash his hands, what happens to his nail polish? It'll come off. By the fact that Byron and the rest of you people know that nail polish does not come off, that tells you that nail polish must be non-polar. So what are you going to need to do in order to get rid of your nail polish, Byron? It's called, yes, use something that is non-polar. It's called nail polish remover. It used to be called acetone, but then they realized that a bunch of people were getting cancer from removing all the polish off their nails, and now they don't put acetone in there. They do something like acetone. It is non-polar. Non-polar. Okay? Like dissolves like. Polar dissolves polar. Non-polar dissolves non-polar. Here's another example. If I had a permanent marker, it would work even better. This, of course, does not get erased by the marker. I know, but watch this. The marker board marker is nonpolar. The green pen that I used is nonpolar. So now the marker board has dissolved the green, and now I can get rid of it. Okay? Like dissolves like. Nonpolar dissolves nonpolar. So this is basically all you need to think about when we're doing these questions. And you'll be doing them in the worksheet. If water dissolves it, polar. If water does not dissolve it, it's nonpolar. So oil, polar or nonpolar? Oil. Can water dissolve oil? No, so it's nonpolar. Grease. Can water dissolve grease? No, so it must be nonpolar. All right, nail polish. Polar or nonpolar? Can water dissolve nail polish? House paint. Can water dissolve house paint? And before you say yes, oh, really? So do you have to paint your house every time it rains? Think about it. If house paint was polar, then every time it rained, your house paint would come off. But watercolors. Yeah, you know, when you were a little kid, you would first dip the brush in water and then you would rub it against the watercolor paints and then it would come off. Vegetable oil, which comes down to if we can't get water to remove the vegetable oil off our pot, what do we have to use? Soap. What's the key thing to soap? Soap has a positive side and the negative side. Is it polar? Yes. Is it non-polar? Yes. It is both. It has a side that's attracted to water, and it's going to have a side that's going to be attracted to the skin, the oil in your skin. Oscar, it is now intervention time. I've had several kids tell me that the smell coming off of you is just outrageous. So I finally got to the point that I called home and your mom says, no, 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 no. He takes a shower every day. And then I said, okay, but does he use soap? She goes, it was like that. She goes, I go, what? She goes, when he was little, he got soap in his eyes and he screamed bloody murder. Okay. And every time I went to give him a bath, he would scream every time I reached for the soap. I go, okay. So what happened when he started giving himself baths or showers? She goes, I don't know. I'm going, that's it. That's it. He has been using water, but he's not been using soap. Okay, see, Oscar and everyone else here, in order for your skin to be healthy, it has to produce oils. So the oils stay on the surface of your skin. Unfortunately for us, there's a creature that loves the oil on our skin. It's called bacteria. Bacteria is everywhere. It falls in our skin. And when the bacteria goes, oh, oil, it starts eating the oil and start producing bacteria poop. The smell that we're getting from Oscar is the smell of bacteria poop. It's not him, it's bacteria poop. Why? Because he keeps trying to get the oil to come off using water. Can the water dissolve the oil? No. So that oil keeps stacking on there until you get the bacteria doing its thing. So what should we do? Let me show you a video. So here is a drop of oil that is on his skin. Well, you can't see it yet. There it is, a drop of oil. Notice the big wormy looking things? That is soap. It has two sides. The green is non-polar. The red tips here, that's polar. Remember, soap is polar and non-polar. Notice what the green is doing. It's sticking to the oil droplet on his skin. Okay? Now, if all you do is use soap, then all it's going to do is it's going to just stick there. But watch what happens when you rinse. So, when you rinse it, the water molecules are going to stick to the ends of the soap molecules and it's going to drag it away. See that? It's going to stick to it, dragging it away and off of his skin. And it's going to go down the drain. Now, if you don't rinse your tub or your shower after every time you take a shower, then what's going to happen is these globs are going to stick to the sides of your shower and form soap scum. Once the water evaporates, it forms that sticky residue that if you've ever tried to clean a shower or a tub, You know what I'm talking about, don't you? Okay, that is that sticky residue that's come off of people. Last thing, water. It is a misnomer. It should not be called the universal solvent, but it is. When I think of universal, I think it dissolves everything. It does not. But there are three things: ionic, polar, and nonpolar. Water can dissolve ionic and polar. It just can't dissolve everything. All right?